Welcome to this video, and in this video I wanted to have a look at why Venus spins backwards. So Venus is quite unusual in the solar system in that it spins the opposite way to most of the other planets. So normally, we know that actually all planets spin. They just spin slightly different to one another, but all planets will spin as they orbit the Sun, and this is true for all planets, not just ones in our solar system. We would expect planets orbiting other stars, so exoplanets, to also spin as they orbit. It would be unusual for them to show no spin whatsoever. So they're orbiting the star or the Sun, they are then also spinning on their axis as well. Now, normally, they would spin the same direction that they orbit the star. So if they were orbiting anti-clockwise, you'd expect their spin to be anti-clockwise, and the opposite. So if they were going clockwise, you'd expect their spin to be clockwise as well. So we always expect it to be in the same direction that they are orbiting their star. Now the reason for that is that planets are going to form in a disk around a young star. So as the star is still forming, you get this disk of gas and dust. The planets basically form in that disk. So there's like a gravitational collapse of material. They slowly grow in this disk, and to conserve angular momentum, the planets then must spin the same direction that they orbit. So as they collapse, they will maintain that same direction of spin. So if the disk is rotating around the star in one direction, as bits locally collapse to form planets, it would maintain that same direction. This is due to the conservation of angular momentum. So they have to spin in the same direction as they orbit, assuming they formed in this disk with the star at the time. So another feature about the spin of all these planets is that they typically all show a tilt to them. So they've been knocked at some point. So Earth and Mars, around about 25 degrees, they've been knocked over their rotation axis. So they're not perfectly aligned with their orbit. That's why we get our seasons and things like that. But if they formed originally, it would have been closer to zero. So what can cause that? Well, collisions with other planets can knock their tilt. So with regards to the Earth and the Moon, we had a collision with a approximately Mars-sized object that collided with the early Earth. This then knocked the tilt over, it formed the Moon, and the Moon is then orbiting kind of in a similar sort of direction to the Earth is spinning. So that was one cause of that. It can also occur due to a close encounter. So instead of an actual collision between two planets, if they actually pass by one another, so you get what is known as like a gravitational scattering event, they would basically pass by one another and one planet may be scattered more than the other. This can then also tilt the rotation axis of a planet as well. So a close encounter can do the same thing and knock it over. Now, going back to Venus, the other odd thing about Venus is that it rotates very, very slowly. So not only does it rotate backwards, it rotates very slowly. So one Venus day is the equivalent of 243 days on Earth. So it takes a very long time to do one rotation. And then one Venus year around the Sun is 225 Earth days. So one day on Venus lasts longer than it takes to go around the Sun. So it's a very slowly rotating object and also rotating backwards. So that's another odd thing about it. Now, it's not fully known exactly why Venus spins this way, but there are a few theories, and I'll just cover two of them really. So you've got the massive collision, which is similar to what we had with the Earth. You have a core mantle friction and atmospheric tides, so there's actually an internal friction which slows it down and then possibly reverses it. And there's a few other ones as well, but I'll just mention these two. So with regards to a large collision, it might suggest that it's not rotating backwards at all. Its tilt's been knocked 180 degrees. So it's been knocked completely 180 degrees, and it's still rotating the same direction, but it's just been knocked completely over. Now, in order to do that, it takes an enormous amount of energy, so it's not particularly likely that this is the scenario, and I believe this was an earlier scenario or suggested mechanism for what did it, but there has been some more recent work done that suggests that it's an unlikely scenario, this giant collision. Where a more likely scenario is that it's going to be down to kind of friction between the core and mantle. So the core and mantle are essentially separate parts internally that have different densities. They are obviously more fluid-like, and there's a friction between the two, which can obviously slow down rotation. There's also atmospheric tides. So from the sun, you've got fairly strong tides. Venus has a very significant thick atmosphere, so you can get these quite large atmospheric tides as it rotates. This can actually cause a bit of a drag to its rotation. It can slow it down, so it can actually slow it down and potentially even reverse it as well. And this mechanism has the potential to explain its current rotation. It's just one of the scenarios really is to give us why it rotates, or why it appears to be rotating backwards, and why it's rotating very slowly as well, is that it's down to this friction, these tides that can slow it down and potentially reverse it. So thank you for watching, and if you enjoy, you can check out some of the other videos.